Welcome everyone to our first Operate First Data Science Community Meetup of 2022. We took a little bit of a break for the holiday, so I hope everyone is able to enjoy their recharge. In the chat, I'm just adding a link to the Operate First Data Science Community page for you all to take a look at. You're here today, but some other places where you can get resources around the Operate First Data Science community, specifically like GitHub repo, YouTube channel that has all of our previous sessions if you're interested in that, or where you can actually suggest on our GitHub agenda board for our GitHub board as an issue to give a talk. Cool. So today we're going to have Elyra talk to us about AI pipelines on Open Data Hub. But before that, I just wanted to open the floor, see if there are any questions anyone had about the meetup or the data science community before we jumped in.
Hey,
All right,
Michael.
cool. Yep.
Oh, sorry, Michael. This is Bill Wright. I'd like to set up a time to discuss a deeper integration with this initiative and the enterprise neurosystem. So I'd love to figure out a time to set that up and get that moving. I've been in touch with Marcel about it in the past, but I'd like to start formalizing that.
Yeah, that sounds great. Thanks, Bill. I will reach out to you on GChat or email, and after the call, we can set that up.
Sounds great.
Perfect. All right, cool. Well, with that, I'll hand it over to Elyra, and she will tell us all about AI pipelines on ODH.
Thanks, Michael. I'm going to try and share my screen here. All right. Can you all see the screen?
Yes.
All right.
Yes.
Okay. And my internet is being a little flaky of late, so please let me know in chat, or please feel free to interrupt me if you cannot hear any part of what I'm saying. All right. So with that, let's jump right in. So hey everyone, I'm Elyra Chatterjee. I'm a senior data scientist in the open services team within the emerging tech group. And in this session, I'm going to talk about how we typically automate our data science workflows using Elyra and Kubeflow pipelines. So what are AI ML pipelines? So your data science project typically may involve different steps like data collection, feature engineering, model training, etc. And there might be different instances where you want to automate these different steps of the data science workflow and run your notebooks or your scripts in an automated fashion, either in series or in parallel. So in such cases, we use AI or AI ML pipelines. They are essentially reproducible workflows that can be used to automate these repetitive steps within a machine learning workflow, and ranging from data extraction, pre-processing to model training and deployment. So how do AI ML pipelines make a data scientist's life easier? So firstly, ML pipelines help automate manual and repetitive machine learning tasks. And it also helps create faster iteration cycles by parallelizing different tasks within a machine learning workflow. Predefined and automated components also lead to better reproducibility and more consistent workflows. And hence, AI ML pipelines are also very useful for enhancing the reproducibility of your ML workflow. And pipelines can also help in better version control and monitoring of machine learning code and the artifacts that are generated, thus making it much easier to track executions. So these are a few of the many reasons why we use AI ML pipelines within our workflows. So what are some tools that we can use to create automated pipelines? So there are several tools starting from MLflow, Argo, Kubeflow pipelines, simple cron jobs, etc., that you can use to create these automated machine learning pipelines. For this session specifically, we are going to talk about Elyra and Kubeflow pipelines, both of which are available on the Open Data Hub project. And we can directly use Jupyter notebooks to create these ML pipelines and automate them in a workflow without having to even translate them into scripts. So Elyra is a notebook pipelines visual editor, which is available as a part of Jupyter Lab, which enables us to trigger Kubeflow pipelines using an intuitive UI from within Jupyter Lab. And Kubeflow pipelines is a platform for building and deploying scalable machine learning workflows. So what are some prerequisites that you would need to set up an ML pipeline using Elyra and Kubeflow pipelines? So firstly, you would need a Jupyter Lab instance with the Elyra notebook plugin. You would also need a Kubeflow pipelines deployment within your project or cluster or environment where you're working in. You would also need a set of Jupyter notebooks or Python scripts, whatever you're working with that you want to automate. And finally, for executing the Kubeflow pipeline, you would need container images that contain the notebook dependencies for the project or for the scripts or for the notebooks that you're automating. So we can take a look at a short demo of how to set up this pipeline and run the notebooks and see the running notebooks or scripts in action from a Kubeflow pipelines UI. So for the purpose of this demo, I'm going to use the OS Climate environment. So OS Climate is essentially a project which leverages Kubeflow pipelines and Elyra. And we are using these tools to automate several notebooks within this project. So let's jump into this directory. So as you can see here, this directory contains these two notebooks, and we have set up a Kubeflow pipeline, which helps us automate these two particular notebooks and run them in sequence. So we can move over to a Jupyter Lab environment and see how this is actually set up. So moving to, so this is a Jupyter Lab notebook image, which I have already spawned. And this already contains the Elyra notebook pipelines visual editor. And using the Elyra pipeline editor, we can easily create these Kubeflow pipelines. So let's take a look at the two notebooks briefly that we want to automate. So as we discussed earlier, the first notebook that we want to automate is the demo one create tables notebook. So this is a simple notebook, which is essentially getting some raw data from an S3 storage location. It is translating the raw data into data frames, performing some conversions so that we can create SQL tables from the data that we collected from S3 and push it to the SQL database engine. And the second notebook, which is the demo one join tables, is getting those tables that we pushed to Trino database engine and those tables and pushing a new table back onto Trino. So we want to automate these two notebooks and create a pipeline out of these. So as a first step, in the previous Operate First Data Science Meetup, we saw how you can create container images from your project using the AI COE and Thought tooling. So using the Thought bots and the AI COE pipeline, we have already created a container image which contains the project-wide dependencies. And this container image is available on the project's query registry. So as you can see here, we have been pushing updated versions of the project's container image onto this query registry. So we can leverage this into the Jupyter Lab environment and add this notebook image to the Elyra metadata. Now, in order to add it to the Elyra metadata, you can look at the left-hand side panel. On the left-hand side panel, you will see there's a runtime images icon. I'm going to click on that, and you can click on the plus icon to create a new runtime image. So for example, let's look at the runtime images that we have already created for this project. So within this runtime image, you would provide an optional runtime image description, a name for this runtime image, and link to the image, the query container image for this project that we created, and hit save and close. The next step for setting up a Kubeflow pipelines is actually setting up a Kubeflow pipelines runtime configuration. And in order to do that, you would also navigate to it. You can navigate to it from the runtimes icon on the left-hand side panel. Now, to create a new Kubeflow pipelines runtime configuration, you can also hit the plus icon here. Let's take a look at the different fields that we need to fill in. So you would provide a name for this Kubeflow pipelines runtime config, the Kubeflow pipelines API endpoint that is available on your cluster. Here we are using Tekton as the Kubeflow pipelines engine. So we are selecting Tekton. You also need to provide the cloud object storage credentials where the notebook is, where Kubeflow is able to store artifacts from and get artifacts from and run and store the notebook's metadata into. So we can provide a Kubeflow, we'll provide a cloud object storage endpoint here. We'll provide the access key and the secret key and the bucket name. Now there's another field here called the cloud object storage credential secret, and providing a secret for this project within the Kubeflow pipelines runtime config prevents exposing of the secure credentials like the access keys and secret keys. So we recommend also setting up a secret for your cloud object storage bucket. So once you have done that, you can hit save and close. Now we have both the important requirements set up for creating a Kubeflow pipeline, which is the runtime image and the Kubeflow pipelines runtime configuration. Next, let's move on to see how you can actually create the pipeline and drag and drop the notebooks into it. So by going to the launcher, by hitting on this big blue icon here, under Elyra, we can go to a new pipeline editor. This is called Untitled.pipeline. So we will give it a name. Let's call it OPF demo. And within this pipeline, we can drag and drop the notebooks which we want to add to the pipeline, and we can simply connect those either in series. And if we want to run multiple notebooks in parallel, that can also be done easily from here. Um, Now, for the execution of each notebook, we also need to set up notebook properties for each step of the pipeline. And that can be done easily by going to clicking on the notebook itself and going to properties and filling in all this information here. So we need to provide the runtime image that we created earlier. We can provide the resources required for running this notebook, for example, uh, one CPU, 8 gigs RAM, etc. Um, we can also provide any optional file dependencies like Python scripts or other notebooks that the notebook depends on here. Um, then we also need to provide the various environment variables that the notebook needs to correctly execute, like the S3 bucket credentials, like the credentials to the Trino database itself, etc. So once we have done that for each of the steps within the pipeline, we are ready to trigger the pipeline. So we have already set up pre-existing pipeline containing these two notebooks and provided the notebook properties for each step. We can now see how to trigger these notebooks. So in order to trigger these notebooks and launch the pipeline, you can hit the run pipeline icon on the top panel, and we can provide it a pipeline name. Let's call it demo one. We also need to select the runtime configuration that we created earlier. It was called demo one AIC OSC. This is the one which I've set up previously, so I'm going to select that and hit OK. So as you can see here, the job has been submitted successfully. Now to check the status of this running Kubeflow pipeline, we can go to run details, and this will essentially take us to the Kubeflow pipelines UI. And as you see here, the first node of the notebook, the first node of the pipeline has already started executing. To view any running logs or debug anything that's going on within this notebook, we can go to click on the notebook and go to the logs tab here. And once the notebook has completed executing successfully, it should turn green and show a green check mark next to it like this. And now you can see that both the notebooks seem to have executed successfully. We can also check the Trino database or the S3 bucket for artifacts to make sure that these notebooks have run successfully. Also, any metrics that we want to track during the execution of the notebooks, such as um, model performance metrics, F1 score, accuracy, and any other metrics that we want to capture during the execution of the notebook can also be captured and viewed from the run output. So like you can see here, we are capturing certain metrics like the number of rows in the table, the time to create the tables, the time to upload, and different artifacts such as these for each of the notebooks. And we are also able to compare these metrics across multiple notebooks and different runs. And this can also help us track model performance metrics and help us version control machine learning artifacts better. So getting back to the slides. So yeah, that was a very quick demo of how you can set up your own Kubeflow pipelines using Elyra and view it in execution and also debug your notebooks. Here are some resources for which you can refer to after the presentation if you want to set up your own pipeline. And yeah, that's it for this demo. Feel free to ask any questions that you might have.
Cool. Thank you so much, Angela. Any questions from anyone? No? All right, cool. Well, that was our presentation for today. We'll be meeting again in 2 weeks. Not 100% sure what the topic will be, but I think likely we'll be continuing this kind of journey of going through the different capabilities of the Open Data Hub platform and how we're using it in our group in the Operate First community.
I actually did have a quick question about the slides. Are those going to be posted as well to the GitHub page?
Yes, great question. We will add definitely a recording of this to the GitHub page, and I think we've been slacking on it, but the slides, when available, should be added there as well. So I think as long as that's all right with Windrilla, which I assume it is, we can add it to the GitHub.
Perfect.
Cool. Anything else? Awesome. Well, again, thanks so much, Windrilla. I really appreciate it. And if there's no other questions or comments, I'll stay on for a few more minutes, but can give everybody else the rest of the hour. And yeah, looking forward to seeing you all in 2 weeks.